Hi everybody, welcome back. We are now going to talk about evaluating functions that are built out of functions at particular value points. So for this example, I am going to look at addition and subtraction. So let's look at the first part. We're going to look at f plus g of 2. And remember, by definition, this is just really f of 2 plus g of 2. Because remember that if we have f plus g of x, that is really just f of x plus g of x. So it doesn't matter if it's an x or a 2. Same rules for substitution apply. If I replace an x by a 2 here, I have to do the same thing on the other side of the equation as well. Let's get rid of all the excess visual noise. And so we want to figure out what f of 2 and g of 2 are. So you can do either inline or you can do some side work. So f of 2, well, that's just going to be 2 minus 1, which is 1. And then g of 2 is going to be the square root of 11 minus 2, which is the square root of 9, which is positive 3. In this case, we're just going to take the positive square root. So we put this all together, and we have 1 plus 3, and that gives us 4. So that's what these two functions, when added together, equal. So let's look at our other example. F minus g of 7 now. So again, like before, we'll have f of 7, this time minus g of 7, and then you want to do some side work again. In this case, we need to figure out what f of 7 is. Well, that's just going to be equal to 7 minus 1, which is 6. Then we need g of 7, which is the square root of 11 minus 7, which is the square root of 4. And again, it's just the positive 2. So this is going to be equal to 6 for the f of 7 minus 2 from the g of 7, and that simplifies to be 4. So that's how addition and subtraction work. And multiplication and division aren't that much different. So let's look at an example of multiplication. So now we want to find f times g of negative 1 for f of x squared equals, or f of x equals x squared plus x, and g of x equals the cube root of x minus 7. So first of all, recall that from the last video, that fg of x is going to be equal to f of x times g of x. So in this case, fg of negative 1 is going to be f of negative 1 times g of negative 1. Again, and if we replace x with negative 1, we have to do the same thing with these two x's as well. So now let's figure out, with a little bit of side work, what these values are. So f of negative 1, well, this is going to be negative 1 squared plus negative 1 by taking negative 1 and replacing this x and this x with it. And this is going to be 1 minus 1, which will give me 0. G of negative 1 is going to be the cube root of 7 minus a negative 1, which gives me a cube root of 8, and the cube root of 8 is 2. So these are my two values I sub in. So this is going to be equal to 0 times 2, and this will give me 0. Our final example is going to deal with division. And so recall that f over g of x is just equal to f of x over g of x. So in particular, if I look at f over g of 2, this is just going to be f of 2 over g of 2. So I need to figure out what these two values are. So for side work, Well, f of 2 is just going to be 2 plus 2, which is 4, by substituting 2 in here for x. And then g of 2, well, everywhere we see a 2, we put in, or x, we see a 2. So everywhere we see an x, we put in a 2, so we'll get 2 minus 3 over 2 plus 1, which gives me a negative 1/3. So this is going to be equal to 4 divided by negative 1/3. And then we're going to flip and multiply. This will be 4 over 1 times negative 3 over 1. And this gives me a negative 12. So now let's change all this. So we are going to now look at f over g of negative 1. No, sorry, of positive 3, excuse me. So, again, this is going to be equal to f of 3 over g of 3. So we need to plug in our values for our side work. So, f of 3, so remind you what f is just x plus 2, so we'll just get 3 plus 2 equals 5. And g of 3, well, let's see what we get. Well, we get x minus 3 over x minus 1, so we'll get 3 over 3 over 3 plus 1, which gives me 0 over 4, which is 0. And this should start throwing some red flags at you, because if I substitute these numbers in, I get 5 over 0. So notice that 3, the number I chose, 3 was not in the domain of f over g of x to begin with. And I just wanted to show you that, you know, if you choose your numbers incorrectly, we'll get 0 in the denominator. Again, that means that this value is undefined for this function. So that is possible with fractions. Anyways, that will be all for this video, and up next will be composition of functions. See you then.